Okay, so we're going to deal with multiplying polynomials today, and it has a little bit to do with dealing with the exponents. It has a little bit to deal with the coefficients, so we're going to see a lot of it. But one of the things is that we're going to deal with some special product rules. And I'm going to go through like the nerd speech of it first, and then we'll talk about how it actually works out, like the short version afterwards. So one of our special rules is that, let's say that you've got something like a term where there's two things and they are being squared in a situation that looks like that. Now, what those two things are doesn't really matter to me. They're just two things that are being added together and then that is being squared. Well, a lot of times you would work that like this. This was back when if I had x plus 3 squared, what that usually meant, what you had to do was that was exactly the same thing as x plus 3 times x plus 3. So far, so good. You guys agree that those are the same things? So if you were going to expand this, if you were going to work this out, you would have to do foiling. You would have to FOIL it out like first times first, outer times outer, inner times inner, and last times last. But when it is the case that it's the exact same thing being squared, there's a little trick to it. So there is a little bit of a trick right here. One of the things that we can do is that you can always do this, by the way, you can always FOIL it out. Like when we say FOIL it out, it's like the first term times the first term, x times x is x squared. You can do the outer terms times the outer terms, 3 times x is 3x. You can do the inner term times the inner term, 3 times x is 3x. And then you can do the last term times the last term, which would equal 9. When you simplify that, that ends up as x squared plus 6x plus 9. However, there's a faster way to do this. And it works like this. I want you to take whatever the first term is and square it. So what is x squared? X to the second power, just x squared. And then let's take 3 and square it. What do I get? No, 3. 3 squared. 9. That ends up as 9. So notice right there, I've already accounted for the very first thing here and the very last thing. The only thing I'm missing are those 2 3x's. And the secret to that is that whenever you've got something squared, you can just take the first term times the second term and then double it. So x times 3 is what? 3x, and then double that and it becomes what? 6x. And if you notice, I didn't have to FOIL that all out. I still ended up as x squared plus 6x plus 9, a lot less work. So check this out. Let's say that I've got x plus 12, actually let's make it a little bit harder here, x minus 12 squared. What is x squared? It's just x squared. And what is negative 12 squared? Positive 144. There's the first two things that you've got to do. What I'm trying to show you here is that you don't have to FOIL everything out like you used to. Finally, all I'm missing is that last term in there and that middle term. And I'm just going to take this times that. So what is negative 12 times x? Negative 12x. Now double that. What is that? Negative 24x. So it's a much faster way of just going through and working out when you've got a binomial times a binomial, like when we've got something squared, something times itself there. So that's exactly what this is showing here, is that notice here, if you take a and square it, you get a squared. If you take b and square it, you get b squared. If you take a times b, you get ab, and you double it, you get 2ab. That's exactly what we're showing there, just the less technical way of saying it. Now, that way also works when they are negatives, and that's what we did, is we showed one with a negative 12 as well. So we took a and we squared it and got a squared. We took b and we squared it and we got b squared. And we did a times negative b, which was negative ab, and then we double it, and that becomes negative 2ab. So it's just a quick way of working these out. Like in Algebra 1, you had to do these kind of the long way, that you were like, you would have had to write it out like this. And then FOIL all that out to get to the exact same answer. So I'm trying to show you, okay, a final situation is, well, what if they're not the same? Notice that this and this are not the same. So a plus b times a minus b. So here's a situation of that. Let's do x plus 4 times x minus 4. And notice that these things are the same here, that here is A, here is A. Here is, let me switch to blue. Here is B, here is B. We are adding one and we are subtracting one. So this is called the difference of okay, so what we've got here is x plus 4 and x minus 4. And what happens there is we are going to end up with something that has a negative in between. It's going to definitely end up negative. And we're going to take the first thing and square it. What is the first thing squared? That becomes x squared. And we're going to take that 4 and square it. What does that become? 16. Now, just to prove that that's a shortcut way of doing that, I'm going to actually do the work over here the long way. A plus B times A minus B. Well, the first times the first, A times A is A squared. The outer term times the outer term is A times negative B, which would be negative AB. And then I'm going to do the inner terms, B times A, that's positive AB. And then finally, I've got B times negative B, which would be negative B squared. Now notice that these two terms are going to cancel each other out, leaving just A squared minus B squared. My point being is you don't have to do it the long way. If you know these three tricks, you can actually cut all of that out of there. You can go, okay, well, I'm not going to do all that work anymore. There are shorter ways of doing it, but you have to be able to recognize those tricks there. So what we're going to do now is put all of this together and do some multiplying here. Now, we are going to multiply some polynomials. Notice here, we are going to take this first term and multiply it times this second thing there, which is just distribution. That's all we're going to do is this. So let's start with distributing in the red there. Let's go through that. When I do that, just that red line, how do I multiply that? We're going to add the exponents for the x's for sure, but what about that 3? What happens with the 3? So here's the thing is, look at this x right there. What is in front of that x? A 1. So let me just put it there real quick, just so that we can see. Now, you don't have to write it there. I'm just trying to illustrate there what happens. 3 times 1 becomes what? 3. So that's the numbers multiplied together. Now I'm going to do the x's multiplied together. X squared times x squared becomes x to the 2 plus 2, which ultimately ends up as what? 3x to the 4th. That's the red part right there. Now we're going to do the blue part. So 3 times 4 gives me, let's do the numbers. So 3 times 4 gives me 12. That's a positive 12. And this x squared has no x's to go with over here, so that's 2 plus 0. So this final thing ends up as what? 12x squared, just like that. Now, those are the steps that I would expect to see in your homework, because without them, I don't know how you're getting those numbers. I don't know how you're turning things into a 4 or to an 8 or to a 6. I don't know how those numbers come about if you're not showing me. Now, you might be like, I have to write all that out. Be like, that's 2 lines. That's 2 lines. If I hadn't been talking and I just did it, it would have taken me less than 12 seconds. Okay, let's try another one. Let's try B. Somebody other than Ozzy who wants to throw themselves under the bus, because I know, Ozzy, you're always volunteering, so I need somebody other than, and then you get the power to throw somebody else under the bus. Barrett, thanks for volunteering. You've been voluntold. All right, so talk to me.
Would you distribute AB?
You sure would. So let me just show exactly what he's talking about there. We are definitely distributing. So this is going to be distributed there, and this is going to be distributed there, and this is going to be distributed there. So we're going to do this in 3 separate steps. So let's start with the red. So the first part is AB times a to the 3rd power. Let's do that. The A's go with the A's, the B's with the B's. So what does that become?
Wouldn't it just be AB to the 3rd again?
Okay, so remember the two things that are the same. What is the exponent on this very first A?
1.
It's a 1. So talk to me about what's going to happen with the A's.
It's just going to stay the same.
Interesting. When I have two things with the same base, what do I do with their exponents?
Add
Add them. So we're going to go like this, 1 plus 3.
Okay.
And that becomes, what does that 1 plus 3 become?
4.
Okay, so we got A to the 4th. Now that B has 1 there, and there's no other B's to add it to, so it's 1 plus 0, which is just 1. So that first part there, that first multiplication, becomes A to the 4th, B to the 1st. If you left out this line, I would be okay, but I definitely want to see the second line, that one where you're actually doing. Oh, yeah, you can leave off. Yeah, his question is this: do I have to put that 1 there? No, actually, you should not put that 1 there. I was just trying to show where that was coming from there. So it really should look like that. A to the 4th B. All right, Barrett, use that same thing, and let's do the blue line right there. So we've got AB times 3AB squared.
Alright, so you would multiply you multiply the whole thing, right?
Well, we're going to do numbers with numbers, A's with A's, B's with B's.
So it would stay 3AB, and then it'd be...
Okay, wait, so 3, like definitely a 3, because there's a 1 and a 3, right? And 3 times 1 is 3.
Yeah,
What about the A's?
It would be 1 plus 2, right?
So what exponent is on this A?
1.
And what exponent is on this A?
3. Or no, 2, I'm sorry.
So this 2 is actually only attached to that one there, because it's inside the parenthesis.
No exponent?
Well, what about that? So what did you say was on this one?
1.
So what do you think is on this one? A 1 as well.
Okay.
So we've got 3A, that's to the 1 plus 1. What about the B's?
You do 1 times 2.
Not 1 times 2, but 1
Plus 2.
1 plus 2. Beautiful. So we've got all that done. We just need to shorten it up now.
So you get 3A to the second power, and then B to the third.
Beautiful. One more and then we're all done. Let's do the green line. So we've got AB times negative B squared.
So when you get A squared,
So A's with A's.
yeah,
What is the exponent on this A? So what?
there's no A, right?
So this A has a 1 on it, and there are no A's over there. So this becomes A to the 1 plus what?
0.
0. Okay. And what about the B's?
B, you do B times B, and you just get negative B, right?
Well, let's talk about this negative at the end. Let's talk about that. Let's just deal with just B's for a minute. Let's talk about the negative at the end.
Alright, so you just get B 1 plus 2.
1 plus 2. So before we move on and shorten this up, what's that negative going to do out there? What is the number that's out front here?
1.
1. What is the number that's out front here?
Negative 1.
Negative 1. So what is 1 times negative 1?
Negative.
Negative 1. So there's a negative 1 in front of all of this. That's what that means. That's what that negative is doing there. Now let's clean this up. A to the 1 plus 0 becomes what?
Just regular 1A.
Just A to the first power or just A? What about this B to the 1 plus 2?
B to the third.
B to the third. Now, am I going to write that negative 1 out front? What am I going to write instead?
Negative sign.
Just a negative sign. Because we don't normally write that out there. Now, last but not least, all you got to do is bring all of this together. So just tell me what to write.
So you get A to the fourth, B, and then when you multiply it, it's times, right?
So this is actually, now we're just going to add these together. Yep.
So plus 3A to the second. Would you add the B?
No, we're just going to write it just like we see it.
B to the third.
Okay, sorry. And the last part?
Negative A, B to the third.
Which of those things can be added together? I'm glad you don't know because none of them. So the only way that things could be added together is if their exponents were exactly the same. Like here I have an a to the fourth and a b to the first. I don't have any other a to the fourth and b to the first. Here I have an a squared and a b to the third. I don't have any other a squared b to the thirds. Here I have an a to the first, b to the third. I don't have any other a to the first, b to the thirds. So this is our final answer right there. I know it feels like a lot of work, but it feels like a lot of work because I am talking us through it. Like you doing this would actually go a lot faster than me sitting here explaining it. So, Barrett, now that you have the power to throw somebody under the bus, who will be under the bus?
I don't know.
All right. What are we going to be doing with that first? What are we going to be doing here? Like, what's our steps? Perfect. So let me just do this. I'm just going to keep doing this over and over again so that if you're not comfortable with it yet, you've at least got something you can do every single time. So our first part is going to look like this. All right. Talk to me.
So this one will be 12.
Okay. 3 times 4 is 12.
And c to the third.
Okay, so it's c to the 1 plus 2, which, as he said, becomes c to the third.
And
D to the 2 plus 1, which then becomes d to the third. There's our first term of our answer. How about the next one? So
3 times negative 6 will be negative 18.
give me 1 second to catch up here. Negative 6c d. And he said 3 times negative 6 would be negative 18. C to the 1 plus 1, and as he said, that would become c to the second power.
And then d to the third power.
D to the 2 plus 1, which becomes d to the third power. His second term is now done. Moving on to the third term.
3 times 14 will be 42.
Okay, give me 1 second to catch up to you here. 14c d squared. 3 times 14 is 42.
And c to the second power.
Okay, c to the 1 plus 1, or c to the second power. I keep saying that 1 plus 1 because I expect to see that part in your homework. And the d's?
D to the fourth power plus 2.
D to the 2 plus 2, which is d to the fourth power. Last but not least, bring it all home now.
So 12 c to the third power, d to the third power, minus 18 c to the second power, d to the third power, plus 42 c to the second power, d to the fourth power.
Beautiful. Is there anything there that can be added together or subtracted? Nothing with the same exponents. There's ones that are close. That first one and the second one are close, but they're not the same. All right, let's do 2 more, and then I'll leave you the rest of the time to work on your homework. Who are you throwing under the bus?
Haley.
Haley, welcome aboard. Let's see. Same exact steps, except for we've got 4 terms that we are multiplying. So it's just 1 extra set of steps there.
You distributed, so the first one's going to be x to the second y times 6y to the third.
Okay.
It's going to be 6x to the second power and y to the third.
Okay, so here's exactly what she's doing. Y. So she said that was 6x squared y to the 4th. Fantastic. Let's move on to blue.
Okay, so x to the second y times y to the second, which is x to the second and y to the third.
So x to the 2 plus 0, y to the 1 plus 2, and she said that was x squared y to the 3rd. Okay, how about the green one?
The green one is going to be negative 28 x to the second power y. Or y to the second.
Okay, so 2 plus 0 and y to the 1 plus 1, negative 28 x squared y squared. And last and certainly not least, x squared y times 30.
30x to the second y.
X to the 2 plus 0, y to the 1 plus 0, that becomes 30x squared y to the first. All right, last but not least, Haley, I think you had the hardest one, but you may have gotten through it the most quickly. Let's put it all together.
6x to y, 6x squared y to the 4 plus
You're right, sorry, I got stuck there. Sorry, go ahead.
plus x to the second y to the third minus 20x to the second y to the second plus 30x to the second y to the y.
And just y there. We don't need to write that to the first power there. Final answer there. Is there anything that we can combine? Just a quick check. Is if there's anything we can combine, we should combine it, like so you don't lose any points. I don't see anything with the same exact variables there. They do both have x's and y's, but not to the same exponent there. I'll leave that up there for those of you who are copying down. All right, Haley, who's going under the bus for the last one? All right. Marco, last one. Now, this one we can just FOIL it out here. Like we can just do, again, the first term times the first term, the outer term times the outer term, the inner term times the inner term, the last times the last. Talk to me. Okay, so 2a times 3a. So when we're doing first, outer, inner, last, that's the first term. Just for anyone who's trying to figure out, that's the first term in each. So, okay, from there, what does that become? 6a to the 1 plus 1, or 6a squared. There's one of our terms. And then let's go, what's next? 2a times 5b becomes 10a to the 1 plus 0, b to the 1 plus 0, which then becomes 10ab. Perfect? Okay, negative b times 3a. So think about this. Does this help? Negative 3a to the 1 plus 0, b to the 1 plus 0, which then becomes negative 3ab. Perfect. And last but not least, so we've got negative b, and I'm going to put that 1 out there just as a reminder, times 5b. Negative 5b to the 1 plus 1, which is equal to negative 5b squared. Are there any terms up there that can be combined? Okay, so these two right here are definitely going to be able to be combined right here and there, because same exponents, same variables, same exponents. So the 6a squared, oh boy. The 6a squared is going to stay that way. And at the end, the negative 5b squared is going to stay the same. But we do need to combine these two terms. What do I get when I combine 10 and negative 3 of something? 7. So a positive 7ab. So 6a squared plus 7ab minus 5b squared. You can see that it's very easy to get caught up in all the work and get lost along the way. That's why I'm trying to do these in steps, because I'm hoping that it'll help out in the long run.